Happy Monday morning. Right. What did we do last time? Was last time transformations? So we finish up our introduction to functions. And so we studied operating from functions, right? Addition, multiplication, composition. And there's one operation left, known as the inverse. What is the definition of a function? It was a relation of a special property. What is a function?
Each possible input value leads to exactly one output value.
And it's a relation in which each input has only one corresponding output. And most importantly, every input has to have a corresponding output. It says nothing about each output having only one input. A function can have multiple inputs going to the same output. This is where the notion of a one-to-one function comes in. While it's not mandatory to be a function, there are cases where each output will have only one corresponding input. That's called a one-to-one function. It is also known as an injection.
Thank you.
There's also what's known as an onto function, also called a surjection. An onto function is just a function whose entire codomain is covered. So the codomain equals the range. We don't really worry too much about that in this course. For our purposes, every function is going to be onto. However, in mathematics, the notion of a one-to-one and onto function, also known as a bijection, is extremely important. I think the first time you'll encounter that in your math career is when you're in algebra. So mathematically, this is what it means to be one-to-one. For every x1 and x2 in the domain of the function f, if f of x1 equals f of x2, then x1 equals x2. That statement is what we're going to be using to prove that a function is one-to-one. Inverse function. For any one-to-one function, y equals f of x, a function let's call it f inverse, is an inverse of f if f inverse of y equals x. Mathematically written this way. These two statements say the same thing. And that is read as f inverse. That is f inverse, not f to the minus 1 power, which would be 1 over f of x. F has domain D, range R. F inverse will have a domain R and range D. So for the inverse function, the roles of domain and range switch. probably the most important result. F of x has an inverse if and only if it is 1-to-1. The second part of that statement is given in the definition of an inverse, where it says for any 1-to-1 function. So that means every single 1-to-1 function has an inverse. However, that doesn't say that a function has to be 1-to-1. That's where the second half of the statement comes in. Non-1-to-1 functions do not have inverses. Again, that's important. Because on a test, I ask you for the inverse of a function. You want to verify that it has an inverse first. You don't want to waste time trying to find an inverse that doesn't exist. So we're going to be given a pair of functions, and we're asked to show that they are not 1-to-1, sorry, that they're inverses of each other. That means we have to show that f of g gives you x, the identity function, and g of f gives you the identity. Remember how to find composition of functions. In the definition for f, replace x with x plus 3 over 2. Two times a half is 1. And then 3 minus 3 is 0. Which leaves you with x. G of f. Look in the definition of g, replace x with 2x plus 3. Minus 3, sorry. It's 2x minus 3, not plus 3. Negative 3 plus 3, that's 0. And 2 over 2 is 1. G of f is also x. So that means f and g are inverses. I think there actually are two other results I probably should mention. If g of x is an inverse for f, then f is an inverse for g. So that is the relational thing that's called the symmetric property. So the inverse operation is symmetric. They kind of say the same thing. And so the inverse of f inverse is just the original function. And again, that is an important property in theoretical mathematics. So once you start studying stuff like linear algebra. Show that these functions are inverses. And notice the restricted domains. So look in the definition of f. Replace x with root x minus 3. Square root of x minus 3 squared is what?
Is it x minus 3?
It's just x minus 3. Gives you x. And keep in mind we were allowed to throw g of x into f, because in g it said that x had to be greater than or equal to 3. So the square root, so g itself is greater than or equal to 0. G of x squared plus 3. Definition of G, replace x with x squared plus 3. Three minus 3 is 0. You're left with square root of x squared. Square root of x squared is what?
X.
What is the square root of negative 2 squared? Does 2 equal negative 2? Which means the square root of x squared cannot be x. How does 2 relate to negative 2 though? They are related.
Absolute value.
The absolute value of negative 2, isn't it? So the square root of negative 2 squared would be the absolute value of negative 2. So what's the square root of x squared? What is it?
Positive and negative x.
How do you write that?
Plus or minus x. I don't know, I'm just saying that shit.
How do you write that mathematically? Plus or minus? Absolute value. But what was the domain for f? Which means absolute value of x is just x. So that means that f and g are inverses. F of g, f of 4 minus x squared. So we're going to look at f, definition of f, and replace x with 4 minus x squared. What are we left with under the square root? What is it? That? You sure? How'd you get it? That's what I'm asking. Notice if it was negative x squared, we'd have a problem. Because x squared is always positive. So you'd be taking the square root of a negative number, which we can't do in the real plane. So it can't be negative x squared. So it's just x squared. That is a very common mistake. That's made a lot, even in the upper level courses. That's why I always put parentheses around what I'm replacing. And what was the square root of x squared? What is it? Which is, how do you write that mathematically? Absolute value of x. What's the domain for g of x? Yeah, which means this would be negative x, which is a problem. F of x should not be that. So I'm going to stick with that for right now because it's going to serve a purpose. Is negative x equal to x? There's only one time where that is true. And that's if x equals 0. But it's not true everywhere else. Which means f and g are not inverses. So that's what f should have been. I just missed the negative when I wrote out the slides. Negative there, which means that's a negative, which means that's a negative. Make that negative x. Just positive x. how did I know that I had a typo on the slides? It forced me to go back and look at my notes. And again, this is something that's also a very common error in math. The question was to show that they are inverses, meaning that they are, and you have to prove it. It's not asking, are they inverses? It's telling you they are. And you have to answer why. So if you get a result, in this case, that says they are not inverses, either you did something wrong, or there's a typo. In my case, there's a typo. Now for G of F. So we're using G and replacing X with F of X. Negative square root of 4 minus X all squared is what? Is that the result of just squaring it?
Yeah.
It's just 4 minus X. Which then when you distribute that negative through, gives you negative 4 plus X. And that's just X. So they are inverses.
Sorry, earlier you said you could put the absolute value why is it?
Yeah, because look at the domain for G. What's the domain for G?
It has to be less than 0.
What is less than 0? X is, right?
Yeah.
X is less than or equal to 0. So the absolute value function will spit out negative the value, right? Because what's the absolute value of negative 3?
3.
How do you get it? Multiply by minus. So we're going to show that this function is 1-to-1 and then find its inverse. So the claim is that f of x is 1-to-1. We have to prove it. Oh no. 5-letter keyword that makes every math major shudder. This is nothing like your high school geometry proofs. Those are not proofs. They're sketches of a proof. So remember, what did it mean to be 1-to-1?
One output corresponds to one input.
And we have to use a mathematical statement.
F of x.
If f of x1 equals f of x2 for all of x1 and x2 in our domain, then that would automatically mean x1 equals x2. That's where we have to start. What's the domain of f? So what's the domain of 4x minus 1?
Negative 10 to the 6.
So let x1 and x2 be real numbers. Such that f of x1 equals f of x2. What we now have to do is we have to show that that necessarily means that x1 and x2 are the same. Well, if f of x1 equals f of x2, that would mean that 4x1 minus 1 has to equal 4x2 minus 1. But that would mean if you add 1 to both sides, you'd have to get 4x1 equals 4x2, right? But you can divide both sides by 4, which means that x1 has to equal x2. Which is the definition of 1 to 1. So 4x minus 1 is indeed 1 to 1. And that's an algebraic proof. We generally don't look at the geometric proof, which is the horizontal line test. Good, it's 1 to 1. Now find its inverse. So find its inverse. We let y be the real number 4x minus 1. We know that there can only be one such y because we just proved it was 1 to 1. So this y is unique. The idea is we want to find what that input is. What is x? So solve for it. Add 1. Divide by 4. So given that specific output, that's how you would find the input. So if I said that y is 3, what input do you need to get an output of 3? One. So 1 corresponds to 3. That's what that says. Given any output, you can find its corresponding input. Now it's just a matter of flipping x and y. So that's your inverse function, x plus 1 over 4. which is, by the way, 1-to-1. That's another corollary. If f has an inverse function, then its inverse is also 1-to-1. Which is also fairly easy. I'm going to show that this function is 1-to-1 and then find its inverse. Right, so the claim that we're proving, f of x equals 2 over x plus 3, is 1-to-1. Bless you. And just as a heads up, if this appears as a test question, you don't actually have to write out what the claim is. I'm only doing that to show what we're trying to prove. What is the domain for 2 over x plus 3?
Is it negative from infinity to -3?
Are you asking me? Or are you telling me?
Yeah, I think it is.
That confident? No, that's not very confident at all. That's not good. That's not good at all. You should have more faith in yourself. That is the domain. Such that f of x1 equals f of x2. Now it's algebra. How would you solve that? I think this was elementary algebra. Algebra 1. Pretty sure equations of this one were algebra 1. Algebra 2, I believe, is more complicated. Rationals. The method would be cross multiplication, right? We don't have to do that here. Because there's another way. The numerators are the same, aren't they? Two fractions are equal if and only if they have the same numerator and denominator when put in reduced form. So if the numerators are already the same, that means your denominators also have to be the same. And if you don't believe me, go ahead and cross multiply. You're still going to wind up dividing by 2 to get the same thing. You then subtract 3, and you get x1 is equal to x2. We get that f has to be 1 to 1, right? Satisfies the definition. Perfect. That shows it's 1 to 1. Which means it has an inverse. Now we're going to find it. This is where using codomain instead of range is preferable. So I don't have to worry about trying to determine what the range of f of x is. It's actually not difficult. The range is everything but 0. But for some more complicated functions, that's a little bit more difficult to do. So I'm just going to use the codomain, which is all real numbers. So I'm saying y is a real number that satisfies y equals 2 over x plus 3. And so again, I'm giving you an output. You want to find its corresponding input. That is your inverse. And how would you solve that? Where would you start? It was already said. There's someone sitting in the back. Cross multiplication. Multiplied by the common denominator, which is x plus 3 in this case. Remember what we're trying to solve for. We're solving for x. So multiply by 1 over y. Add negative 3. There's your input. Now that is an acceptable form. That form would be acceptable. I'm pretty sure WebAssign would accept that. Unless they specifically ask you to write it with a common denominator. So I would accept either of those. Unless I ask to fully simplify. And full simplification, you have to give me that one on the right. And you can always check that you got the right inverse. Just plug it back into the original function and make sure you get x. If you don't, then you did something wrong. I would encourage you to check your test. Unless you're just absolutely confident in your math. So show that x squared minus 9 for x greater than or equal to 0 is 1 to 1. Then find its inverse. So that is the claim. F of x equals x squared minus 9 is 1 to 1 for x greater than or equal to 0. Before we even tackle it, why is that true? Right? Intuitively speaking. If you can see why it's true before starting the proof, it really helps. Hmm? What if I didn't have the x greater than equal to 0 there? Would it be 1 to 1? Hmm? And for the sake of argument for right now, let's say that bit isn't there. Which means I'm getting rid of that. Would that be true? Why? What did you use for? What did you use for x? That's how you're going to work. So this is how you would disprove a statement, by the way. You provide a counterexample. So what does the square do? Let x be plus or minus. Let x1 be -1, let x2 be +1. What's f of -1? -1 squared is 1, I agree. Let's subtract 9. What's f of 1? F of -1 equals f of 1. Is -1 equal to 1? No, there's your counterexample. It's not 1 to 1. But now think of what happens. Oh dear. When I now add in that restriction, well, now you've just eliminated all the negative values. Can you think of two positive values that when you square them give you the same thing? Two different positive values squared being the same. That's why it's 1 to 1 now. So pick two non-negative numbers such that f of x1 equals f of x2. Again, the goal is to show that this necessarily means x1 and x2 are the same. That would mean that x1 squared minus 9 has to be x2 squared minus 9, right? Which would mean that x1 squared has to equal x2 squared. Which means that their absolute values have to be the same. However, we have the restriction of them having to be non-negative. So since x1 and x2 are greater than or equal to 0, that would mean that x1 has to equal x2. Again, the only time that the absolute value of x1 equaling the absolute value of x2 is true is if x1 and x2 have the same magnitude, but just possibly different signs. Right? So negative 5 and 5 would have the same absolute value. But we removed the negative numbers. Thus now it's impossible to have two different values. And so we have our function being equal to 1. We should specify 1 to 1 for our given domain of greater than or equal to 0. Now we can find its inverse. All right, so let y be some real number satisfying y equals x squared minus 9. Solve for x. What would you do first? Yes, solve for x. You could, but how does that help? You'd only want to do that if it equals 0. That's just x squared minus 9. Isn't it? Right, we can easily isolate x just by adding 9. What would you do then? Number x. How do you get rid of that x squared? You theoretically could, but again, that doesn't help. Because then you have x equals y plus 9 over x. You don't want to define x with itself. How do you get rid of the squared? Square root. But remember what we're told about x. Has to be greater than or equal to 0. That leaves us with the square root of y plus 9 for x. Which means our inverse would be the square root of x plus 9. Just for fun, what is the domain of that inverse? So what's the domain for square root of x plus 9?
Negative infinity, negative 9, negative 9.
So how did you get that?
Because
Why can it not equal 0?
oh, never mind.
Is it? What happens if I throw negative 10 in? What becomes negative 1? Is that a problem? In the real plane? Yeah, that's a problem, right? Oh, that's an issue. That means you can't have negative 10. So that right there means it can't be all real numbers. Because we just now saw that it can't be negative 10. So what could you throw in for x? What is the smallest number you're allowed to take the square root of? So what aren't you allowed to take the square root of? Can't take the square root of 0?
Negative numbers.
So the endings are negative.
Well, again, if x is just non-negative, I would say, okay, what about -8? What's -8 plus 9?
Oh,
Can you take the square root of 1?
yeah.
So I can't have negative numbers in there. So if you're allowed to take the square root of 0, and that's the smallest you can take, what is the smallest value of x such that x plus 9? Or what is the value of x such that x plus 9 is 0? And everything larger than -9 will give you a positive number, right? So there's your domain. -9 to infinity, including -9. Which means your range for x squared minus 9 is -9 to infinity. Remember, the inverse flips the roles of domain and range. So the domain of the inverse would be the range of the original function. I wonder if that's important later. To show that this function is 1 to 1, that's the claim is our function is 1 to 1 for x less than or equal to -3. What's our domain? What is it? -infinity to -3? Is -3 included?
Yes.
Right? They actually gave you the domain. So we're picking two numbers, x1 and x2, between -infinity and -3, such that f of x1 equals f of x2. What would we do first? Remember what we're trying to show. We're trying to get to x1 and x2 being the same. So what should we do? matrix or FOIL? You theoretically can. That's going to make it a lot harder. Get rid of the 4s. Those two expressions have to be the same. Which tells us what? What is it? So don't skip the steps. If the square of the values are the same, what about the values themselves? Do they have to be the same? The actual values themselves. Right, so again, if one side is 25, the other side is 25, does that mean that they both have to be 5? One could be -5, right? So it's not the values that have to be the same, it's the magnitude of the values that have to be the same. So this is where we're at right now. However, we know that if x is less than or equal to -3, doesn't that mean that x plus 3 is less than or equal to 0? So if we take the absolute value of x plus 3, where we know that x plus 3 is non-positive, that would have to be the negative of x plus 3. So we use that to get to negative x1 plus 3 has to equal negative x2 plus 3. Multiply by -1, add -3. And we get that x1 has to be x2. You're doing that. This is still an easy proof in mathematics. You get a lot worse than this.
You start calc
technically even in this course, some of the proofs are like the proof of the fundamental theorem of algebra that we're going to be looking at. That's pretty bad. So it's 1-to-1. Now we can find its inverse. Since again we're given a real number y, such as the output, we want to find the input. Add 4. Take the square root. However, we know that x plus 3 has to be non-positive. So that means that negative square root of y plus 4 has to be x plus 3. So there's x. And there would be our inverse function. Negative 3 minus the square root of x plus 4. And again, you can use this to easily find what the range is for f. Range would have to be 4 to infinity, inclusive. Right, because the domain of f inverse would be 4 to infinity inclusive. So the range is 4 to infinity. That's why there's a class dedicated just to inverse functions. Questions on inverse functions? Not necessarily. I could just say show that this function is 1-to-1 without asking for the inverse. However, you do know that if a function is 1-to-1, it's going to have an inverse. Now, every 1-to-1 function has an inverse. This idea of inverse functions is important. We'll be revisiting it again. And again, if I remove that condition with x being greater than or equal to 0, That function is no longer one-to-one, which means it does not have an inverse. So I could put on a test, find the inverse of x squared minus 9, if it exists. And the answer would be, it doesn't exist. You don't want to waste time trying to find that inverse function because there is none. We are now done with week 3 already. So these assignments are coming due. You have one due tonight. Also means next week, or Wednesday starts week 4. Which means there's a quiz at the end of week 4. That also means that the week after that is your first test. So 2 weeks from today is your first test. And I already have it written. It's fine. See you on Wednesday.